Okay, how many studies do we need to perform a meta-analysis? 5, okay. If you're going to do a fixed effect analysis, let's say we're back in the condition of the drug company that has, that has run a series of studies and knows that they are all identical because that's the way they've sampled them, then even 2 studies is enough. I mean, you're going to get an estimate that has half the variance of one study, and why not do it? On the other hand, if we're talking about a random effects analysis, where the studies that we're looking at have been sampled from a universe of populations, then in order to do that properly, you need to get an estimate of tau squared. And in order to get an estimate of tau squared, you probably need at least 4 or 5 studies to get any kind of a decent estimate. As I think I started to say yesterday, I mean, it seems to me that with any less than 6 or 7 studies, this estimate is going to be very imprecise. But as a practical matter, in Cochrane, the median number of studies in those analyses where they're actually able to do a meta-analysis is 6, which means that some of them are 5 and some of them are 4, and so people do that. My sense is that once you have 5 or 6, you probably are okay. If you have less than that, certainly if you have 3 or less, it's tentative. At that point, you might decide one of 2 things: either I'm simply going to present the 3 studies or the 2 studies without combining them, or you might decide to do what I mentioned yesterday that Richard Pito suggests, which is to do an analysis which simply is a descriptive analysis of the studies that you have in front of you without trying to extrapolate to a wider universe. Somebody, I think it was you yesterday, asked if we can do this Bayesian thing where we say, well, what if tau square was this? That actually does make sense. At the moment, there is no program, not this one, not any of the others that will do that, but we're looking about incorporating that in a future version. You had a question?
So your guidelines are about 4 to 7. Does that also apply to subgroup and moderator analysis?
You probably would want to have, I should be clear. I mean, almost everything, I think pretty much everything that I've told you is basically, things that have been established as the conventions in the field. This number that I'm coming up with over here, I've heard discussions of this kind in many of these professional groups, but people have all kinds of ideas about this. I would not feel comfortable saying that this is a convention that all people in medicine have accepted or all people in the social sciences. You can go back to the journals that you're thinking about publishing in and seeing what people do. I don't, I just don't know of any evidence that says, with this number it makes sense and with this number it doesn't. I'm not sure what people, there are so many different fields, so I don't really feel comfortable giving really good advice. This is my personal opinion about, where it starts to just make sense and where, as far as subgroups, I think if you have, 4 studies in each subgroup and you're pooling the estimates of tau square, basically that estimate now is based on 8 studies, which is a reason why I would want to pool those 2 estimates, even 3 in each subgroup. And certainly, God knows, if you go back to Cochrane and you're looking at subgroups analysis, you're lucky to find, in many cases, you're lucky to find 3 in each. I mean, the problem is, if this is the best evidence that we have, you need to use it. My dad needed they recommended that he do some kind of a procedure a number of years back. And I asked the doctor, does this work? And he says, well, it's worked in my experience. And, and you ask him how many of these procedures, he's done. I mean, he wasn't a surgeon. He sent people occasionally to the surgeon. Well, 12 or something, whatever it might be. I went to Cochrane, and it turns out that this was a very effective procedure, very safe, very effective. But now I had evidence that said this is a reasonable thing to do. Often, we have to make a decision. My dad, fortunately in that case, the evidence was there. My dad didn't have the luxury of waiting until some more studies were done. But if all that you have are 2 or 3 studies, and that's the only evidence you have to go on, it's better using that than simply, shooting blindly. So, yes.
Yesterday you talked about the prediction interval.
Yeah. Yes, I'm still planning to get to that later on today. Also, I have a spreadsheet. If you have that spreadsheet for chapters 14 to 18, in there it shows you how to compute the predictive interval. However, it's a fairly large spreadsheet. What I've done is I've just sort of isolated the 4 lines that you need to compute that and put that on a separate spreadsheet so that you can use that. What I'm planning to do is to annotate it and then send it to everybody. It's one of the reasons I needed your email, but I can show you how that works a little bit later. Okay, I also, yes?
Is there conventional wisdom, obviously the way to include more studies is to get a little more messy in your inclusion criteria.
Yeah.
You know, in the world that I'm in family studies,
Yeah.
we have clinical trials, it's never that clean anyway.
Yeah.
So is there kind of a conventional wisdom of which poison to choose, whether you have, less power because you only have 4 studies,
Yeah.
but they're very precise and very constrained?
I would say there's no conventional wisdom, nor could there be. It really is a case-by-case thing. We were talking about some examples yesterday where kids were sent out into the wilderness to have some kind of an experience, and then the question is, did they benefit? And the outcomes were all over the place. But the larger question is this: does this thing in general have good outcomes? And you might have a case, where you're looking at the intervention of a drug. I think, if you're Congress or the Department of Education, and you're trying to see should you fund these studies, then the general question, we have, and this actually I think yesterday I mentioned was a case that I saw. The Department of Education gave out many millions of dollars to fund dozens and dozens of different interventions. Some of them had to do with tutoring, and some with mentoring, and some with all different kinds of things. And then they had dozens of different outcomes. So the only thing they had in common was that they helped the kids. And Congress wanted to know, this money that we've spent, did it have a positive effect? So they didn't care to distinguish between whether the outcome was improved grades or less dropouts. They didn't care to distinguish between whether the intervention was a different teaching procedure or tutoring. They just wanted to know, was our money being used effectively? So in that context, this made sense. As a researcher, to me, that's less interesting. The question is, if I go in with this particular intervention and this particular outcome, what is the impact going to be? So these are all legitimate questions, and each one has an appropriate sampling framework. Okay? You're also, as you said, are limited by the kinds of studies that are available. I suspect that sometimes people go into a literature search thinking they're going to find 100 studies that address a very specific question, and it turns out there are only 3 or 4. So then they have the option of doing the analysis on those 3 or 4, which might be a completely legitimate thing to do, or of expanding the criteria and getting another 20 or 30 studies, but with a less focused question. These are entirely substantive issues and very good questions to ask, but the answer really, I think I mentioned to somebody yesterday that every meta-analysis really should be led by people that have a substantive understanding of the field, with statisticians playing a very important support role. Because you have to know what are the relevant questions, what are the relevant things, on which to include or exclude studies, and what might be, and things of that sort. Let me continue with this. I'm going to stick around later. I want to make sure we have a chance to cover all of the key issues. I do want to point out that we've been talking about a kind of meta-analysis which relies on summary data from each study. There are other kinds of meta-analyses as well. I mentioned before that Rosenthal used to work by combining p-values. It's very rarely done anymore, and obviously vote counting is something that we don't want to do. There's something called individual patient meta-analysis, and now it's been expanded to be individual participant meta-analysis. The idea over here, and I'm sorry to use the example of a drug company again, but it's the one where this most often applies, is that rather than working with the summary data and saying, that we had, 10 events out of 100 people and 20 events out of 100 people, you actually go back and get the data for every individual patient in that study. And the reason that drug companies can do it is because they own the data, they have it, and many studies coded the data using the same variables. The advantage of using individual patient meta-analysis is that if you have a covariate like age, rather than saying the mean age in this study was 50 and the mean age in that study was 40, you actually have the age for each individual patient. And therefore, if you're trying to pull out noise, you're able to do it at a much finer level. And you get a more accurate, a better estimate of the effect size. You're just getting rid of some of the noise. I've never done one of those. For people that work at drug companies and have the option of doing it, it's certainly a good idea. But you can never do that by working with papers that you picked out of the literature. I discussed this yesterday, what kinds of studies would we want to include. And this, again, goes back to your question. You can define the criteria very, very narrowly. So the studies, for all intents and purposes, are identical. You're going to get a very precise estimate of a very specific intervention with a very specific population. That's rarely done. You can define the effect, you can define the question a little bit more broadly. So you're asking if this intervention is effective using the kinds of people where it's generally going to be used. Maybe we might decide that we only want to use adults, not children, that we only want to use a certain dose of the drug, but we've defined it broadly enough so that we can generalize from this to the kinds of things that we might see in the clinical world. We can define it even more broadly so that now we're including all ages and all doses and everything else. At this point, we would expect to see a lot of variance, and either we'll be able to report that the effect is robust across all of these things or that it varies. And finally, as I said yesterday, we can actually specifically look to find studies that differ on high dose versus low dose, and then see what impact that has on the effect size. Okay, criticisms of meta-analysis. I might have mentioned yesterday, when I used to teach workshops, I'd spend a couple of hours explaining why meta-analysis is a useful tool. Because people used to show up. I remember giving a lecture once at Hebrew University at Hadassah Medical Center in Israel, and I stood up to talk about meta-analysis, and before I could say anything, the guy says to me, "Let me tell you why you're wrong." And I said, "First, let me say something, then tell me why I'm wrong." I'm happy to say that after a couple of hours, he actually came over and said, I really didn't understand these things. I really appreciate it. And now I've been convinced this is something I want to look at much more carefully. But there was a time when meta-analysis was considered what was considered black magic. Clearly, the people in this room are here because they've they understand that this is a useful tool and want to learn how to use it. Nevertheless, I've cut this part of the lecture down from 2 hours to about 15 minutes, but I think it's worth giving you a sense of context. Back in 1997, in the New England Journal of Medicine, this fellow called John Baylor III published an editorial where he said that he doesn't like meta-analysis. And he says, any attempt to reduce results to a single value with confidence bounds is likely to lead to conclusions that are wrong, perhaps seriously so. So the first thing that I thought of when I saw that was this guy. There's a great scene in one of the Inspector Clouseau movies where he shows up at an inn, he's trying to get a room. And he says to the innkeeper, he goes through this whole thing about, nice to, right, catch your plane, okay. Thanks. Okay. He goes through this whole series of things. He finally gets a room, and he's leaving the sort of reception desk to go up to his room, and he sees this little dog sitting next to the innkeeper, and he's going to go over and pet him, but then he thinks better of it, so he says to the innkeeper, "Does your dog bite?" And the guy says, "What?" He says, "Does your dog bite?" And the innkeeper says, "No, my dog does not bite." He reaches down to pet the dog, and the dog rips off his sleeve. It tries to grab onto him. It rips his sleeve off. It jumps on him, knocks him down. Finally, he pulls himself up, tries to, regain a little bit of dignity. And then he turns to the innkeeper. He said, "I thought you said your dog does not bite." And he said, "My dog does not bite, but that is not my dog." So it's the same sort of thing over here. John Baylor is absolutely correct when he says that if you take a bunch of studies and you put them together, and what you try to do is to come up with one summary number, and that's your goal, that is a mistake. But what I think should be clear to everybody by now is that is not the goal of a meta-analysis. The goal of a meta-analysis is not to compute a summary, it's to do a synthesis. The first thing that you do is you see the studies in context. So you see whether or not the effect size is consistent or whether it varies. If it turns out, as it did, for example, in the Canon study, that the effect sizes are consistent, then you get a more precise estimate of the effect size. You're able to say that they were consistent. You get a narrow confidence interval. You get much increased statistical power. If it turns out that the effect sizes vary, then you can use that variation in assigning weights. You can talk about the variation. You can talk about the substantive impact. That's the way a meta-analysis should be done. The next thing that we hear again and again is that you're mixing apples and oranges. If you actually do a Google search for apples and oranges, in fact, one of the books on meta-analysis has a picture on the front of an apple and an orange. Bob Rosenthal, and the criticism says, you're trying to synthesize data from studies that may include different populations, different protocol, different study designs, and the summary effect may ignore important differences among these. That's a picture of Bob. Bob said, mixing apples and oranges makes sense if your goal is to produce a fruit salad. And I think I mentioned yesterday that Julian Higgins said, oh yeah, the analysis may include apples and oranges and indeed melons and pears. But used properly, the fact that you have this diversity of studies is actually a strength rather than a weakness of the analysis. What I would say is that if you look at all the studies, it might turn out that the effect size is very consistent from one study to the next, in which case you can conclude that the effect size is robust within this universe of studies, however you've defined that. Or it might turn out that there's moderate variation, in which case, let's say that over here the risk ratio varies from 1.15 to 1.25. You can say that there's always a risk of secondhand smoking always increases the risk, maybe by a little bit less, maybe by a little bit more, but all of those fall within a range where I would consider that to be a risk. Or if we're talking about a drug, maybe the reduction of of heart attacks in some studies is 40%, in some studies is 60%. Those are all within the clinically important range. Or it might turn out that if you group by low dose versus high dose, then in one case you're getting a very small effect, and in one case you're getting a very large effect. The point is that if you do only a single study, and it happens to be a high dose study, what you know is that it works. You don't have any way of knowing what the impact would have been if you used a low dose, because you're only looking at one study. If you're doing a study on juvenile delinquency and you see that there's some effect, you don't know what would have happened if you had a population that was different in some way, or an intervention that was different in some way. By contrast, when you do a meta-analysis, you can actually look at these things empirically. If you have one study, and this is the effect that you get, you can only speculate about what would happen if you had other studies, but when you actually have those studies, you can see what happens. The last point that I want to make is this fellow called Laurier and colleagues wrote this article in the New England Journal of Medicine. In the New England Journal of Medicine, by the way, after John Baylor wrote that editorial, I believe that there was not a single meta-analysis published from 1997 until the Avandia meta-analysis, which was only about 2 years ago. Whereas in BMJ, over that same period of time, they published hundreds of meta-analyses. They took a completely opposite approach. But in the New England Journal of Medicine, this fellow wrote this article where they made 4 or 5 arguments against meta-analyses. And one of them was they said the meta-analysis may yield different results than the randomized clinical trial. And the thinking was, since we all know that the randomized clinical trial is the gold standard, if the randomized clinical trial yields one result, whereas the meta-analysis yields a different result, clearly the meta-analysis is wrong. Well, it's really worth spending 2 or 3 minutes on this. The first thing is the way that they defined the discrepancy, where the meta-analysis and the RCT disagreed. The way they defined the discrepancy as one of them had a p-value less than 0.05, and the other one had a p-value greater than 0.05. So let's take the situation over here. We have 5 studies that were included in the meta-analysis. Every one of them has a risk ratio of 0.80. And then that was the meta-analysis. And then afterwards, there was this new clinical trial which was done, which has a risk ratio also of 0.80. So all of them have exactly the same effect size. If you go back to the first 5 trials that were included in the meta-analysis, each one of them has a sample size of 800. So not one of them, in this case, the null effect is over here. So none of them is statistically significant. Everyone has a p-value of 0.65 because of low power, but when we combine them and we have a sample size of 4,000, the p-value is 0.013. So the meta-analysis lets us conclude that the treatment is effective. Then somebody comes along and does a new clinical trial. They get the same risk ratio, but again, because their sample size is only 800, they get a p-value of 0.65. By Laurier's logic, there's now a discrepancy because this is statistically significant And this isn't statistically significant. I mean, this is wrong on so many levels that it's just really strange. But I mean, clearly, the randomized clinical trial is consistent with the other trials. It has exactly the same estimate of the effect size. The only difference between this and that is that the randomized clinical trial is underpowered, whereas the meta-analysis is not underpowered. So to say that there's a discrepancy over here completely misses the point that the effect size is exactly the same. Obviously, he didn't, in the examples that he gave, there were none that were as clear as this, but there were some where this was the discrepancy that he was talking about. The second thing is that just logically, the meta-analysis incorporates data from 5 randomized clinical trials. If Lelourier is arguing that the clinical trial, the randomized clinical trial, is the gold standard, well, the meta-analysis has 5 times as much gold standard information as that single trial at the bottom. And therefore, even if there was a discrepancy, to argue that this one is right and those 5 are wrong, again, it's hard to argue that makes a lot of sense. Now, this is one kind of discrepancy. There actually are cases where the effect size in the meta-analysis was different than the effect size in the single large trial that followed. But this would be an example of that where it actually makes a lot of sense. Let's say that there were 5 trials that were done over a period of years, let's say beginning in 1970 and continuing up until 2000, and you did a meta-analysis on those, and this is the mean effect that you get. And then in 2005, a new randomized clinical trial was done, and they get an effect over here. The effect size that they're getting over here really is discrepant. It is discrepant with the effect size that we found in the meta-analysis. However, a reason for this might be, and we actually have seen many examples of this in the literature, is that the standard of care has changed over time. Maybe we are using an intervention which, back in 1970, that was this intervention was the only drug that the patient was being given that had this particular impact on their condition. But over time, everybody is being given drugs that have more or less the same effect. So as you go on in time, the impact of this drug is going to diminish because people basically are getting the same thing anyway. If you did the meta-analysis properly and you recognize that there was this trend over there and you did a regression, you actually would predict that the next effect size is going to be over here, which is exactly where it turns out to be. So basically what Lelourier is saying over here, even though that wasn't what he said, but if you sort of read between the lines, if you did what Baylor is saying you shouldn't do, if you actually just compute a summary effect and don't look at the context and you come up with a single number, that is going to be a mistake. But again, that's not what we're supposed to be doing. And if you have a meta-analysis where the effect sizes vary, you would try to understand why they vary. In this example, it's pretty clear why they vary and where the next effect size is going to be. And in fact, that's where it turned out to be. Where in the research process should we think about doing a meta-analysis? I've sort of been talking about this the way most people think about it, which is that we want to find out, we want to get some evidence for whether a treatment is useful or not. We go out, we do the analysis, and we publish it. But it turns out that there are other places where you might want to think about doing a meta-analysis. One thing is for identifying which areas to study. In other words, people were thinking back in the 1980s that it might make sense to go out and look at studies that might, this was back when sudden infant death syndrome was was a major risk factor for kids. And I guess they were thinking about whether to go ahead and do some studies looking at this, obviously observational studies, the thinking being that if you put the kid to sleep on its back, that it's less likely to die in its sleep than if it was put to sleep on its front. And before starting new studies, they went out and did a search of literature, and it turns out there had been a very large number of studies that already looked at this. And nobody had ever taken the time to put those studies together. When they did, they discovered that the studies provided overwhelming evidence that putting babies to sleep on their back was likely to decrease the risk that they would die of sudden infant death syndrome. But the point is that by going back and finding out what's actually there already, we might avoid going and doing a study which really doesn't need to be done. You can use meta-analysis in designing new studies. If you go back to the literature and look at studies that were done in the area that you're thinking about, it's often possible to say, well, you know, these 10 studies looked at this as the outcome. They looked at BPRS, and they tended to have very small results. But the ones that used CGI as the outcome had much larger results for the same kinds of interventions. Maybe CGI is a more, it's a more powerful measure of the thing that we're trying to measure, and that's the thing that we should be using here. Or maybe, you know, these kinds of populations turn out to generate larger effects. So it's a good way of preparing for a new study. I think one of the most important potential uses of meta-analysis is in grant applications. You know, very often you read a grant application and it says, you know, we're going to go look at the impact of X on patients, and you know, this is something that people don't know, and therefore it's important to study it. Imagine how much more powerful that is when what you do over there is you have a meta-analysis. This is, you know, this is a literature search. These are the studies that address this question. To date, using this information, we just don't have an answer. And therefore, our study is going to address this, and after our study, this is the information that we're going to have, and this is where the state of information is going to be. And in fact, if you include a forest plot, it's so clear about exactly what information exists and what information doesn't exist. Just the fact that you've taken the time to do that is going to impress the reviewers. But additionally, you now have, you know, information to work with. You have an estimate of what the true effect size might be. You have an estimate of how much variation there might be. You have a clear tabular description of you know, what studies were done and what weren't, and what the weak points were and what they weren't, and how you, and it really shows that you've thought about this. Not only does it show that you thought about it, you have thought about it, so that when you go ahead and do your new study, you'll be able to power it, you know, properly and get information about the important factors and so on. And finally, there's the, you know, the thing that people generally think of when they think of a meta-analysis is the publication. This is Ian Chalmers. He's not related to Tom Chalmers, although they once thought they might have been related to each other, but turns out they're not. He wrote this article called Discussion Sections in Reports of Controlled Trials Published in General Medical Journals, Islands in Search of Continents. And the thrust of this was that what you always see, what you almost always see when you open up a journal, whether in medicine or in psychology, somebody says, well, you know, there were these studies out there that were done, and we looked at them, and, you know, they tell us nothing, and then, but I'm going to, you know, publish my magnum opus, and that's going to be great. He says, you know, the whole endeavor, science, medicine, social science, it is a collaborative effort. He says, what if, you know, you actually publish a paper where you say, you know, here's the state of information as it was before, as it is now. This is what we were able to do in our study, and now this is the new state of information, incorporating that plus our study. I guess I said a similar thing when I was talking about grant applications, but it really captures a very important thing. People, in their opening section, in their introduction, pay lip service to the idea that there are studies that came before, but it's almost like, you know, pro forma. They don't really think about what those studies contribute. If you then take your study and add it to that and do a meta-analysis that shows, that puts all of this in context, that is a really much more, a much more useful endeavor. You're sort of putting the whole tapestry together rather than you know, having these islands in search of continents. He also published this other paper called The Lethal Consequences of Failing to Make Full Use of All Relevant Evidence about the Effects of Medical Treatments, the Importance of Systematic Reviews. Ian Chalmers is not known for his subtlety. But he's making a very valid point. I mean, somebody goes out and they start a new study because, you know, they have some drug they want to look at. It really, you know, behooves us as researchers to find out what's available out there, and think of our new study in the context of other studies that have been done in the past. In fact, he did this chart. I think he went through some number, okay, the Lancet, the New England Journal of Medicine, BMJ, JAMA, and a couple of others, classification of discussion sections in reports of randomized controlled trials published in 1997, 2001, and 2005. So here we have in May 1997. Is this the first, this is all for primary studies. The primary study that's being published, okay, if it's the first study addressing the question, we'll give them a pass. They have no way of talking about prior studies. But if it contains an updated systematic, okay, and some of them contain an updated systematic review integrating the new results. 4 of them discussed the previous review but did not attempt to integrate the new results. And in 19 out of 26 cases, there's no systematic attempt to set the results in the context of other trials. You see, in 2001, it was 27 out of 33 that made no attempt to do that. In 2005, it was 10 out of 18. It's actually, I think part of his point is probably that this is improving, at least based on the small sample sizes, but it's something that really makes a lot of sense. As far as reporting standards for meta-analyses and systematic reviews, I would suggest that depending on what field you work in, I would look at some of the journals in that field and look through the systematic reviews and see how people do it. I've discovered, for example, that in BMJ and in the European Heart Journal, the reviews, they tend to follow a format which is very good. They begin by putting everything in context. They explain what their inclusion criteria were. They talk about how many studies they started with, how many they excluded for each reason, and so on. And it's a format that I found very helpful to use as a model. The Cochrane database is extremely good. They have the luxury of publishing online so that each of their reviews runs about 200 pages. However, they always start at the beginning by 1 or 2 paragraphs that gives you the synopsis of the review. And even if you're not technically oriented, if you're a consumer rather than a researcher, you'll be able to understand it. And then they have a more elaborate discussion, and then even a more elaborate one that would be comparable to a published paper. And then they have all of the rest of it in an appendix. But it's really a good place to look. And then if you're working in the social sciences, there's Psychological Bulletin. The thing that might be most useful is this thing called PRISMA, which is some kind of an acronym. And that, as I said before, was put out by a consortium of people working in various journals, David Moore, Douglas Altman, a number of others. You actually have that in your handout. Additionally, Hannah Rothstein was kind enough to provide me with this website. And if you go there, you'll see there's a whole table linking to all different places that talk about reporting guidelines. There's Prisma, and then this is just a picture of the top, but you can scroll down. And there are reporting standards for various different fields, and it's I found that it's very useful. So you have that, and hopefully that will be helpful. I think I have just a couple of more things I want to talk about before we take a break. Let me people okay to go for a few more minutes? Let's see, what time is it? 3:15. What time is the break scheduled for? 3. Okay, let's take a break then, and we'll. Sorry, I get. Yes, sure. Okay. Okay.